Hello everyone, welcome to Informatica support videos. My name is Vidya and I am part of Informatica Global Support. In this video, we will be looking at how to configure stop words in Elasticsearch in MDM. The agenda for the video is to understand what stop words are, how they are applied to analyzers, and how to configure them in Elasticsearch for MDM, followed by a quick demo. Prerequisite is that we should have Elasticsearch configured. Stop words are high-frequency words in our dataset that carry less useful information. Example: a, the, is, are, etc. Elasticsearch provides a stop token filter to remove stop words during search and index analysis. For example, we have the input text field with the value "a quick fox jumps over the lazy dog." During the analysis process, based on the tokenizer used, the text is split into tokens which form the token stream. When we apply a stop token filter, it will remove all the stop words based on the stop word list from the token stream. You can see that a and the has been removed from the final token stream. Stop token filter is applied on analyzers. Let's look into analyzers in more detail. Analyzers are used during search and index analysis. They can be built-in or custom. They use a combination of the three components in the following order. So firstly we have character filters, then we have a tokenizer, then we have token filters. So let's say we have an input text which we want to index. Firstly it will go through a series of analysis rules. So we have character filters, then tokenizer, then token filters. At the end of the process we will get process tokens which will be further sent for indexing. So we can build our custom analyzers using a combination of 0 or more character filters, 1 tokenizer and 0 or more token filters. We can see this in action using Analyze API, which will show us what tokens will be generated based on the analyzer components we use. This is a very useful API to test our analyzers. We will execute the Analyze API against the organization index. Let's take the input field, all the 24 quick brown foxes. We will be transforming this input field using the analyzer components we just saw. Since the input has few HTML tags, we would like to cleanse the text. So we will apply the character filter called HTML strip, which would get rid of the HTML tags from the text. We would also want to apply a tokenizer so that we can convert the text into tokens. So we are using the whitespace tokenizer, which will split the text into tokens whenever it encounters a white space. Let's run this API to see the output. The following tokens have been created after removing the HTML tags. So far we have used the two components of the analyzer. Let's also add the third component, which is the token filter. So we will be using the stop token filter that will remove the stop words from our token stream. Let's run this API. We can see that the has been removed from our token stream. Previously you could see the in the tokens. Now it has been removed. So by default, the stop filter would omit all these words from our token stream. So to summarize, a character filter would perform cleanse operation on the input text before tokenization. In our example, we wanted to remove the HTML tag, so we used the HTML strip character filter. A tokenizer would convert the text into tokens based on the tokenizer we specify. For example, a whitespace tokenizer would break text into tokens whenever it encounters a whitespace. Once tokens are generated, we would use token filters to add, remove, modify these tokens before indexing. For the complete list of available analyzers, please refer Elasticsearch website. Stop words improve the search performance because the index size reduces when we remove the unwanted words, and also the computation time decreases. We will look at the use case to understand this better. Say we have a field called organization name, and these organization names usually contain words like limited, LLC, org, etc. Let's say we have a million organization names in our database and we have indexed these organization names. Then this is how the inverted index for an org name, the Dreams LLC, would look like. It is a term in document metrics. The terms the and LLC are quite common and appear in majority of the documents. However, Dreams can be found in fewer documents. Now, if we run a search for the term the Dreams LLC against the organization index, Elasticsearch would in turn fire three queries, one for each term, the, Dreams, and LLC. These queries would run against million documents in the index. Let's suppose the and LLC match with 500k documents and Dreams matches with 20 documents. Then Elasticsearch would have to compute the relevance score for at least 500k matching documents and return the sorted results based on the relevance score. This large computation can be avoided if we optimize the index by avoiding the common words and adding them to the stop list. So the next time we retrieve search results for the Dreams LLC, Elasticsearch only has to calculate and sort relevance score for 20 documents that match with Dreams. This would lead to improved performance. Point to note is that the words in stop list should be chosen based on our dataset and use case. Configuring stop words in Elasticsearch. By default, in MDM, stop words are listed in a file called stopwords.txt under Elasticsearch config analysis. We can look up the path by navigating to provisioning tool. Under configuration infrastructure settings, Elasticsearch index, index settings. As you know, stop words are part of token filters. Currently, there are two stop filters created, English stop and Japanese stop. So here's the stop words path specified. Stop words are added one word per line. Similar terms are grouped alphabetically for readability. Let's navigate to the stop words location. This is the stop words file. As you can see, all the required stop words are added here. They are listed alphabetically and grouped together. The file is common for all the indexes by default. You can also configure different stop word list for each index by creating custom analyzers via provisioning tool. We have already seen what analyzers are and the three components they are made up of. We have the following default analyzers available in Elasticsearch and MDM. And as you know, we need to choose one of these analyzers to assign to our business entity field while making it searchable. So for an example, if we go to our person business entity and we look at any searchable field, we can see the search analyzer drop down. So these are the available default analyzers that we saw. Now heading back to our index settings. We cannot modify these default analyzers to use a different set of stop words, but we can create a new stop word token filter, specify the required attributes like type, ignore case, true or false, and stop words path in the JSON format. And after creating this token filter, we can create a new analyzer. We can assign the new token filter to it. If there are 3 nodes in the ES cluster, we need to place the stop words file on all the 3 nodes. There is another way to verify the analyzer settings for the index, and that is via the index settings API. We can run this API for organization index and view the current analyzers. We can scroll to the part where we can see the various analyzers. So these are the listed analyzers, and we saw these analyzers earlier via provisioning tool also. We saw text general and all the filters being used in it. We can also see the various token filters being used under filter, where we can see English stop and its path. Let's see a quick demo. We will navigate to E360. We'll select the organization business entity and we'll search with asterisks to see how many records in total we have. So in organization we have around 1200 records. Let's search for the word ink. So around 700 records have the word ink in them. So it is definitely a high frequency word and can be added to our stop word list. We'll navigate to the stop word directory. We can add ink next to in and save this file. Now we will have to delete the indexes for all the BE and recreate to take into account the modified stop word list. Let's look at the current indices. So just for demonstration purpose, we will be deleting the organization index and then run the search again. So in provisioning tool, modeling and the organization business entity, say for example for Duns number field, we enable searchable. We are changing the organization business entity configuration just to delete the organization index. We'll publish the change. Now we can verify via the API if the organization index has been deleted. We can see that the doc count for organization index is now 0. So we will run the reindexing job. We can see that the organization index have been recreated. We'll now search for ink in the organization entity. And we can see that now 0 records are returned, which is the expected behavior as it is part of the stop word list now. The following approach is recommended for updating the stop words list. For demonstration purpose, we had deleted the index for only the organization business entity by changing its searchable configuration. Since our default stop words file is common for all the indices, we need to delete all the indices by deleting the data nodes folder. We can recreate the indices by running the index job for each business entity. For more details, you can also refer the following knowledge base articles. Let us know if you have any feedback or comments on this video. You can email us at supportvideos@informatica.com. You can also follow us on Twitter. We hope the video was informative. Thank you for watching.